All right, so I'm not sure if I have this recording right now. I'm gonna figure out afterwards, but how's it going? Appreciate you being able to give me a little extra time on this. I've definitely had a tough quarter to say the least. So I believe you can see my screen here. It's my first time trying to attempt something like this. But I went with the first question, the one that was dealing with the thiamine. The total weight of thiamine in the said cup of coffee was going to be 599 milligrams. So I went ahead and broke that down on a piece of paper, a little more old school. As far as the math, I do believe the math is correct. Units in it, probably not the prettiest looking thing, but let's go through the coast work here. So I'm just going to break it down with the template that you have before us. So let's see, I've got our question here, optional. Why did I choose this one? Initially, whenever I looked over it, I knew what they were wanting to, what type of answer is going to be. I already knew it was going to have Avogadro's number in it. So I figured might as well go with my gut feeling, go with the first one. Let's see, so collect and organize. So what are we solving for? What should the units be in the final answer? So it's going to be the amount of carbon atoms that are in 1 cup of thiamine. Like I said, the likely to be something that's 10 to the 23rd atoms at some point. Let's see, what information are you given? So we do get thiamine's atomic structure. It's going to be the C12H17N4O, or C, yeah, OS. It's a little late, sorry. Let's see, so the next bit of information we get is the weight of thiamine in said cup. That's 599 milligrams. I'm going to end up using that as grams though, since we're going to be dealing with moles. It's going to make it easier to convert. So on the next bit of analyze, what are we going to need? We're going to need the molar mass of thiamine. So I'm just butchering all the spelling over here. We got the molar mass of thiamine is what we're going to need. Molar mass of carbon, easy. The percentage of weight that carbon is in said thiamine. And we're going to need Avogadro's number to help us with converting the information that we need to the answer, going from grams to moles to atoms. Let's see. So how will we connect the information? You need to solve this problem. Like I was just saying, we're going to take the total mass of thiamine in said cup, multiply it by the percentage of what carbon's mass is in that thiamine. And then from there, we're going to take that number and multiply it by Avogadro's number to find my answer of how many carbon atoms are in that thiamine cup. So here we go. Here's that lovely work I was mentioning, where I was going through the process. I'm hoping you can see my mouse over here too. So we start at the top. It's actually 2 different sides to this, so it kind of splits left and the right. So on the left side here, it does convert, or I did convert the 599 milligrams to grams. So it's a little scrunched there, but that's 5.99 grams. To the right of that, I was getting the total molar weight of thiamine. So pretty much just adding up all of those parts, like carbon being 12.01 grams per mole, and that times 12. And then we're taking hydrogens times 17, nitrogens times 4. And we've got oxygen and then sulfur. Coming together, we got 265.35 grams per mole. Let's see. So here on the left side, on the second part of that, it looks like I am taking the percentage of what carbon is in thiamine. So to the right of that is where I did the math to see that carbon happens to be 144.12 grams per mole. I'm not sure if I scratched that out there on purpose, but what that happens to break down to is it's 54.32% of the total weight in thiamine. Now, I take that 54.32%, I'm going to multiply it times the 5.99 grams thiamine, because a little over half of that thiamine is going to be carbon. So a little bit over half of that, nearly 6 grams there, is going to be carbon. So from there, that gives me 3.254 grams of carbon. And what I've done from there is I divide that by carbon's molar mass, just to see how many moles there are of carbon in that nearly 6 grams of thymine. So a 3.254 grams divided by 12.01, it's going to give me 0.2709 moles of carbon. And I'm going to take that number, multiply it by Avogadro's constant. And from there, it's going to give me our answer. So 1.6314 times 10 to the 20, forgive me, I got scrunched there, times 10 to the 23rd atoms of carbon. So I did try to plug that into the Canvas page there, just to get a little bit of a better answer there, because it's a little bit scrunched. So again, that's 1.6314 times 10 to the 23rd atoms of carbon. Last bit, so think, does your answer make sense? How do I know? Yes, I was expecting those exponents in the beginning. And another bit is that carbon has a molar mass that's more than twice the size of the total weight of thymine. So it does make a lot more sense to be saying that we're below that even 6.022, because that would be 1 mole once converted. So there's not even a whole mole of carbon in that one cup of coffee. I believe that's good on this. I'm hoping that I recorded this correctly. Yeah, thank you for your time.